Okay, guys, today we're going to talk about 6.2, and 6.2 is all about reducing roots and problems that have fractional exponents. How do we manage them? How do we combine them and simplify them down? So we're going to go through a few problems. First one we're going to look at is number 7. It has 80 to the 1/4 over 5 to the negative 1/4. There's a couple of different ways to handle this. What I'm going to do is I'm actually going to go ahead and move this 5 to the negative 1/4 up to give it a positive. Um, I need the 1/4 to be identical for me to do any combinations. So this is equal to 80 to the 1/4 times 5 to the 1/4. Instead of dividing by 5 to the negative 1/4, I'm going to multiply. In other words, I moved this up, and when I did that, it became a positive 1/4. Now, because these are both in a fourth root, essentially, that's what this 1/4 power means, a fourth root. So that means that I can multiply the 8 by the 5 to get 400. And rather than talking about the 1/4 power anymore, I want to talk about the fourth root of 400. And so what I'm going to do is I'm going to split this, okay, because I'm looking for groups of 4. I'll take I'm going to go with, make sure I'm getting the right number, I'm going to go with the 2 and 200. And the 200 is 2 and 100. That's 2 and 50. That's 2 and 25. So right here I see that I have 4 2's. Okay, so the answer that I'm going to accept initially is 2 times the fourth root of 25. This is okay with me. The text is going to have it written a little bit differently. And it has to do with the fact that 25 is really 5 squared. And so this could also be written as 2 times the fourth root of 5 squared. Now this piece right here could be written as 5 to the 2/4, which 2/4 from the 2 and the 4 reduces to 1/2. So this could be 2 times 5 to the 1/2, which is what the book has, or 2 times the square root of 5. Either one of these is also acceptable. They'd probably be more preferred as far as the text is concerned, but I'm certainly happy with that version as well. So we move on and look at number 14. We have 13 to the 3/7 over 13 to the 5/7. Again, the textbook's going to disagree with us in the way we write our answer. But the one rule I want you to emphasize is not to give me fractional exponents in the denominator. So if I subtract 3/7 and go downward, I'd get 1 on top because it would go to 0 exponent. And then down here, 5/7 minus 3/7 would be 2/7. So I'd have 1 over 13 to the 2/7. The problem is that leaves a fractional exponent in the bottom. So what I'm going to do is I'm going to subtract 5/7 and get 13 to the 3 minus 5 is negative 2/7. And then this down here, 13 to the 0 is 1. So that gives me 13 to the negative 2/7. Again, the book's going to disagree quite a bit with that. Normally we don't like to leave that negative there as a negative exponent, but we're going to assume, we're going to accept it for today. 21 has the fourth root of 36 times the fourth root of 9 over the fourth root of 4. And so we're going to go through and evaluate this. Because all of these live inside of a fourth root, what we actually can do is the fourth root of 36 times 9 over 4. And internally, the order of multiplication division doesn't actually matter. 36 over 4 is really just 9, and 9 times 9 is 81. So it leaves me with the fourth root of 81, which there's lots of ways to get it, but if we split it up, we get 3 and 27, which is 3 and 9, which is 3 and 3. You can see that we have 4 3's, which tells me the answer is 3. 28, looking at 28, this one's a little bit different because you may not be sure what the answer you're looking for is. 1 over 6. I'm going to split this, okay, and I'm also going to change this so it's a cube root of 1 over the cube root of 6. Cube root of 1 is 1, so this is 1 over, and I'd rather write this as a fractional exponent, 6 to the 1/3. Problem is I don't like this fraction down here. I told you not to leave fractional exponents in your denominator. So this is going to be equal to 6 to the negative 1/3. Again, the book is not going to agree with that answer, but that's why I'm going through this process. Not to mention that you wouldn't get that answer for 28. It's not in the back of the book, so you wouldn't have to compare. 36, we just have a couple more. 36 has 6 times the cube root of 5 plus 4 times the cube root of 625. I look here at the smaller root first. Does 5 break down to give me a perfect cube? No, it does not. So then I want this to give me that 5. So I'm going to sort of put a box around it. I need a 5 left over so they match at the end. That would leave me with 125, which breaks down as 5 and 25 and 5 and 5. So there's my 3 5s, okay? So 3 5s are going to come out as a 5, and then 1's left behind. That leaves me with 6 cube root of 5 plus this 5 multiplies by 4 to give me 20, and I'd be left with the cube root of this 5 here. Now because they have the same root, identical roots, we have 6 plus 20 is 26 times the cube root of 5. And that's it. And then last but not least, 49. These, I didn't really go into these in class, and so if you have questions about them, I understand completely. But on 49, you start with the cube root of x squared times the 6th root of x to the 4th, all raised to the negative 3rd. Okay? And we want to be able to evaluate this. Well, written the way it is with these roots, it's going to be complicated to work with. So I'm going to write that as x to the 2/3 times x to the 4/6 to the negative 3rd. And, well, 4/6, that should reduce to 2/3. And so when I multiply x by x, I add the exponents. This is x to the 4/3 to the negative 3rd. And if I multiply, it gives me x to the negative 12 over 3, which is x to the negative 4. And because that's a whole number, it can go in the denominator. So this is 1 over x to the 4th. If it had been something like 2/3 or 1/4, I'd have left it with a negative. But because I can push it to the denominator, I'm going to go ahead and do that. Guys, I know I went kind of quick through that, but the rules are rules we've dealt with in the past. It's just applying it to the specific problems with division and these fractional exponents. Otherwise, good luck. Let me know what you need help with when you come to class, and have fun with it, okay? Good luck.